Hi, this is Prithvi Prabhu, UR16CS309. I'm here to explain about queue and circular queue. Queue is a type of array which works on the principle of first in, first out. The first element to get into the queue will be the first element to get out of the queue. Any queue will have a front and a rear element. The front element is the first element and the rear element will be the last element in the queue. Any element which is added into the queue will be added in the rear position, and any element which is removed from the queue will be removed from the first position. Let's move to the program so that we can understand queue. Here I've declared queue of a size 10, and I've given the front as -1 and rear as -1 because any array will start with index 0, and because my queue is empty, I'm giving it as -1. If I add any element, I have to change the front and the rear according to the first element's index and the last element's index, and then the queue functions which I have included here are enqueue, dequeue, and display. These are the three functions through which I can add or delete or to display the queue. First, we'll move to the enqueue function. It is used to add any element into the queue. I have given two conditions in that. First condition is rear is equal to 9. 9 means the size -1. If the rear is present in the last index, it will say queue overflow, that is the queue is full. Otherwise, if the condition is not true, first, if the queue is empty, the front will be -1, and so if we add any element, the rear will become 0 and also the front will become 0. And after that, furthermore, if we add any elements, the rear will increase by 1, and the element will be stored in the rear position. And next we move to dequeuing. Dequeuing is to remove any element from the queue. In dequeue, I have given three conditions. First one is if the rear is -1, that is again the rear, if the queue is empty, the rear will show as -1, and so I have given this condition. If not, if the element is present in the first index, the rear will also show 0 and the front will also show 0. If that is the case, the element will be removed and the front and the rear will be again moved back to -1, and the element will be dequeued. And for the third condition, that is if the rear is not -1 and if the rear is not equal to the front, the position will be changed, and so the front element can be removed easily and the front element will be increased by 1, so that the first position will become empty. And now we are moving to the display function. For display function, I have given two conditions. First, we have to check whether the queue is empty or not, as we checked earlier, and then furthermore, to display all the elements, I am using this for loop, and each and every element present in the queue will be displayed. When we are moving to the main function, I am asking the user whether to enqueue, dequeue, display, or exit. I am doing this in a do while so that the user can use as many times until he wants to exit. Inside the do while loop, I have used a switch case, and according to each cases, the functions will be called. If that is case 1, if they press 1, it will go to enqueue and dequeue, display, and exit according to the things they press. Let's see the output. It's asking for enqueue, dequeue. I'm giving 1. now I've added two elements, and here it is showing 1 2, which is the queue elements which I've added. Now I'm going to dequeue. Sorry, I'll run it again. Now I'm dequeuing. See, it's showing 1 has been dequeued. It was the first element I entered, so it's the first element which gets out. And now if I display the queue, it will show only 2, which is the only element present in the queue. This is how queue works. Circular queue is just a bit different from this, in which if the first element gets removed, the space becomes empty, and in linear queue we can't add any element in that position, but in a circular queue we can add any element in the space empty. That is, if we keep on removing the first elements, the space will be empty. The first index is from 0 till the front, it will be empty. So any element further after the rear becomes max can be added in the empty positions. Here again it's the same somewhat, front -1, rear -1, and here I've declared the max position as 5, and the queue and its position and its size as max, that is 5. Again I'm going for the in queue. In which I have given again 2 conditions. That is, if for enqueuing if the queue is full, we cannot enter any elements. For that, it is not needed that only the rear should be at max and the front should be 0. It can be anything like the front is 2 and the rear is 1. Then also it will be full. For that, I am giving this condition: front is equal to rear plus 1 modulus max. Max is the maximum number of elements. If I give this condition, automatically it will check whether the rear element is next, that is below the front, or it is in the max position. And if it is true, it will result overflow, that is queue is full. Otherwise, the element will be added in the rear position. If the rear is, as I said earlier, if the rear is present in the max, and if we want to add an element and the first indexes are empty, some indexes are empty, elements will get added into the first index, and the rear will change from the max to 0, because the first index is empty. If the front is 1 and the first index is empty, the rear will change the position to 0. Accordingly, it will increase. And again, when we are moving to dequeue, again, if the rear position is -1, it will show underflow, that is queue is empty. And for normally, if the rear is equal to front, same thing as said earlier, that element will be pushed out and rear and front will become -1. Or else, if the front element is present somewhere in between 2, 3 something, and the rear element is present somewhere behind like 0, 1, or somewhere in the max positions, the front element alone will be pushed out, that will be dequeued, and front will increase as usual by 1. To display we are giving different conditions here, because again if it is empty it will show empty. If the front is less than rear, that is if the front is between, below the max position, the elements from the front to the rear will be displayed. Otherwise, if the front is somewhere like 2 3 and then rear is somewhere like 0 1 2, front the elements from the front to the max elements will be displayed first, and then followed by the elements from the index 0 to the rear position will be displayed. That is how display function is used here. And again we go usually to the main function where we ask the user to enqueue and display, and accordingly according to the user's choice the functions will be called. Thank you. Let's run circular queue and see. See, I have given 5 elements already, so it is showing queue overflow. And now I am dequeuing. One is dequeued, see, so the front portion will be empty. And if I display now, it will show only the rest elements 2 3 4 and 5. And now if I add any element, it will be added in the last. See, it is showing 2 3 4 5 0 1, and after 5 the elements get added. This is how it works. This is how circular queue works. Thank you.